This conference will now be recorded.
In last session, we were discussing about what is config map, what is secret, and how we can refer key value pairs, arbitrary data as an environment variables. And also we discussed how to mount config map as a values to our Kubernetes pods using config maps and secrets. So today we'll try to understand about one more important concept called liveness probe and readiness probe. Probes, basically health checks. We have a concept called liveness probe and readiness probe, basically health checks of our applications. So by default, Kubernetes is going to check whether the process is healthy or not. It is not going to check whether the application is responding or not by default. So when we created a pod, when we schedule a pod, kubelet is going to just check whether the container process is running or not, healthy or not, right? But if the container process is healthy, but the application which is running inside that container is not working due to some reasons, does pod will be restart? I mean to say, does container will be restarted in that case by default? Let me ask this question one more time. I have a Kubernetes pod. I deployed one application. I have a Kubernetes pod. Within the pod, I have a container. Within the pod, I have a container. So let's say Tomcat container. Tomcat process is running, but the application which I deployed, let's say this is not responding. Is it going to consider this as a failure? Is it going to restart your container? I mean to say container process by default. If the Tomcat process is healthy and the application is not responding, is it going to restart the process? No. So by default, Kubernetes will just check the process, the container process is running or not. It doesn't check whether the application is healthy or not within the container. But using this probes, using this liveness probe, readiness probe, right, we can control the health of the application running inside a container. This liveness probe and readiness probes are used to control the health of an application running inside a pod container. This is very, very important also. Let me take this use case. I have a pod. I have one application which I have hosted in my Kubernetes cluster. I have hosted within my Kubernetes cluster. Let's say I have 2 replicas. Same application, let's say this application, just to give an example. I have hosted here also. To access this one within the cluster or outside the cluster, we have a service. Let's say the application is not healthy in this pod. The application is not healthy in this pod. The Tomcat process is running. Application is not healthy. Application is not healthy. Your pod is running. Pod is running in the sense your container is running. There is no issue with process, but application is not healthy. So if anyone is accessing via service, if the service send the traffic to this pod, If the service send the traffic to this pod, if the application is not responding, whoever is invoking that service, will they get a response? If this application is not healthy, will they get a response? No. So in that case, will it cause a problem? Will it be a problem? Even though pod is healthy, your application is not responding. In that case, will it cause the problem in the applications? Yes. Now, it is not going to restart on its own. If this application is not healthy, it is not going to restart that container on its own, and the service also will not stop sending the traffic to this pod. Service also will not stop sending the traffic to this pod, and the container also will not restart on its own by default, right? But I want to handle these kind of scenarios. If this application is not healthy, I don't want the service to send the traffic. I don't want service to send the traffic. If the application is not healthy, I don't want service to send this traffic. And if this application is not healthy, I want to restart its process. What is process? Container is nothing but a process. Inside the container, you are running some process. Container is nothing but a process. Inside the container, you are running your process, right? So the process is running, but application is not responding. That can be any process. That can be Java process if you are running a jar file. That can be a Tomcat process if you are running a Tomcat. That can be a Python process if you are running a Python application. That can be a Node.js process if you are running a Node.js application. So the process is running, but the application is not responding. That is possible, right? So pod is running, but our application inside a container is not running due to some memory leakage, due to some application, I mean to say CPU problem or application deadlocks, right? Application is not responding, and application is in a error state. It is stuck into the error state. So by default, kubelet will not do anything. Kubelet will not ask service to stop the sending the traffic to this one, and kubelet will not restart this container on its own by default, right? But if I am going to use these probes, liveness probe and readiness probe, using this liveness probe and readiness probe, what I can do, using liveness probe and readiness probe, I can perform the health check on the application. Using this liveness probe and readiness probes, I can perform the health check on the application, on whatever application which is running inside that container. I can perform the health check. So if the liveness probe health check failed, what it does? If the liveness probe health check failed, what it does? Basically, if the liveness probe health check is failed, right, it will restart the process. It will restart the container. Which means it is going to stop the container and again start the container. Sometimes if it is going to stop and start, does these kind of issues will be resolved automatically? You are going to stop the Java process and again start. I mean to say the container. Is it going to resolve automatically sometimes if you restart the process? Generally, yes. So the liveness probe, if the liveness probe is failed, right, it will restart the container. There might be a deadlock. If you are from application background, you can understand what is deadlock, what is memory leakage. Garbage, right? If you are from a Java background, you can understand what is heap memory, what is garbage collection, right? Suppose application developer has written some junk code. He is creating objects and he is not making sure that those objects are released after its use. So heap memory will be consumed. If it is not properly garbage collected, you will run out of memory issues. I mean to say, no heap space kind of things. In that case, your application will stop working. If you restart your process again, maybe it might resolve that issue, or deadlock threads, multi-threading, deadlock issues, right? So if the liveness probe fails, it will restart the container. It might solve the problem. And if readiness probe is failed, what it does? Readiness probe is used to detect if container is ready to accept the traffic or not. Which means if I have a liveness probe, if I have a readiness probe, unless until readiness probe is successful, does this pod will be reflected in service endpoint? Does this pod will be reflected in service endpoint? Service have a endpoints. Service have a endpoints, right? So unless until the readiness probe is successful, which means this pod is ready to serve the traffic, the pod will not be reflected in service. Which means if the readiness probe is failed, does the service will send the traffic to this pod? If your application is not healthy in this pod, the service will send the traffic to this pod. If the readiness probe is failed, if the readiness probe is failed, the service will not send the traffic to this one because the endpoint will not reflect in the service. If the liveness probe is failed, it will restart. If the readiness probe is successful, then this pod will be reflected in your service. So using this liveness probe and readiness probes, can I perform the health on my application so that I can make sure service will route the traffic to only healthy pods where my application is healthy? And also, if something is wrong, it will restart on its own if the liveness probe is failed. So basically, this liveness probe and readiness probes are kind of a health checks within the Kubernetes pods and service. Simple guys. In AWS, load balancers, did we discuss health checks? AWS load balancer also was performing health checks, if you remember. If the health check is failed, does load balancer is sending the traffic to that server? If the health check fail, does AWS load balancer will send the traffic to that server? It won't, right? Similarly here, this readiness probe is like a health check on the application. If the readiness probe is failed, does that pod will be reflected in service endpoint? Which means, does that pod will be removed from that service endpoint if the readiness probe is failed, so that the service will not send the traffic to that pod? That is how readiness probe works. The liveness probe is basically, it is going to restart the container if the liveness probe is failed. Let me show you. Let me practically show by simulating that issue. I'll simulate that issue and I will show you. Let me connect to my Kubernetes machine. So let me delete this. All these applications I'll delete, whatever I have, so that I can demonstrate clearly. You might already know why I am deleting every time before I am demonstrating new one. It doesn't mean we cannot deploy multiple applications. We can deploy multiple applications, but why I am deleting? Because of the resources available in my cluster. My cluster is very small. I have just 1 GB RAM and 1 core processor, just 2 servers. So that's why I'm cleaning up every time. But in real time, you will have hundreds of deployments. You will have hundreds of pods running in your cluster. Okay. Now, let me take this application. Let me take this application. Uh, let me take this application. You already know all these HPA and all those stuff. For some time, I will remove this HPA 71 to 96. Now I have a deployment, let's say, with 2 replicas. Now we already discussed all these things, configmap, how to mount. If you required, you can keep this. Otherwise, you can remove this one also. Now, let's say I'm creating 2 pods now, and I am creating a service for that also. Now I have these pods up, I think in which namespace? Okay, test namespace. Okay, fine. In this namespace, I created a pods. Now, here, as of now, it is not performing any health check on my application. It is just identifying based on the process. Since the Java process, the Tomcat process is successfully running, here it is showing ready. But even though this application is ready, within that pod, let's say our application is not working. By default, is it going to restart this container which is running in that pod? Does your service will stop sending the traffic to that pod by default? If you see, I have a service, and how many endpoints I can see for now in that service? 2. Now, for some reason, I am intentionally making that application failed in one of the pod. In one of the pod, I am intentionally making that application will stop working. Just I am deleting. I am intentionally deleting, guys. I am intentionally deleting that var file. I cannot simulate that deadlock issue. I cannot simulate that memory leakage issue. So I'm just simulating by just deleting that var file within that pod, that application. So within this, we have this within that container, within that pod. Here we have this var file. Now I'm intentionally deleting this var file just to simulate that application is not running healthy. I'm intentionally deleting that file because I cannot simulate that scenario. Now, if you see, now that application is not running. Just to simulate, I have deleted that. If you see, that application is not running in that pod. In this pod, that application is not running. Now, if you see, it is showing it is running because process is running. There is no issue with the process, the Tomcat process, which is running fine. It is showing running the service. The service also have 2 endpoints. Now, when I try to access this one, the service, if the service route the traffic to this pod in which my application is not there, am I going to get a response now? Am I going to get a response now? If the service route the traffic to this pod, this pod, right? Let me show you. I'm just using service IP. That application, java-web-app. If you see, one time I am getting a response, sometimes I am getting 404, you can see. Sometimes I'll get a 404 round robin. If you see, am I getting a 404? Am I getting a 404 now? Request is going to that pod, but I am getting a 404. 404, page not found. Kind of unhealthy. Kind of unhealthy. When the request is processed by that pod where my application is not healthy, I have issues. If you see, if the request is going to another pod, I am getting a response. If the request is going to one more pod, 404. Which means, will I have a problem now here if this scenario happens in your pods in Kubernetes? Now, how to handle these scenarios? How to handle these scenarios? I don't want my service to send the traffic to that pod, which is not healthy. I don't want my service to send the traffic to the pod, which is not healthy. How can I make sure that service will not have that endpoint where that application is not healthy? In that case, can I use this readiness probe? Can I have a readiness probe defined so that it will detect whether your your pod is ready to accept the traffic or not? By performing the health on that application, we can use readiness probe. If the readiness probe is failed, this will be removed from that service endpoint. So in that case, the service will send the traffic to only healthy pods if I have a readiness probe defined for my pods, my applications? Yes. Now, if I define a liveness probe, what it does in this case? If I would have defined the liveness probe, what it does? It would have restarted. It would have restarted this container. We can perform the health on the applications using liveness probe and readiness probe. What are the ways? How many ways we can perform the liveness probe and readiness probe? Liveness probe and readiness probe, very, very important. So, do we need to use both? You tell me which one I need to use. If I don't want to send the traffic, the service should not send the traffic to the pods. Which one I should use? Do I need to use both? You tell me. If my service don't want to send the traffic to the pod, which one I should use? Readiness probe. Just readiness probe is sufficient. At the same time, if I want my container to be restarted, if the health is, if it is not healthy, at the same time I want my container to be restarted automatically. In that case, which probe I have to use? Liveness, right? Liveness probe. So liveness probe does one thing, readiness probe does other thing. Does liveness probe will remove the service? I mean to say, does it remove the endpoint from the service if I have a liveness probe? No, it will just stop and start your container. But who will actually inform service, don't send the traffic to this pod, you remove that endpoint from your list? Who does this thing? Readiness probe, right? So readiness probe does those things. But ideally, in real time, we are going to use both. We will use readiness probe so that service will not send the traffic unless until that is ready. And also at the same time, we will use liveness probe so that it can restart. The restart may fix the problem. If the restart fix the problem, then if the readiness probe is healthy, then does the readiness probe update service so that you can send the traffic since it is ready? Again it is ready so that you can start sending the traffic. So that is how it works. Okay. Now, liveness probe and readiness probe, how can we perform, right? There are three ways you can perform: HTTP health checks, HTTP health checks, TCP health checks, or you can execute a command and perform health check, right? So who is going to execute these liveness probe, readiness probe instructions? Basically, the kubelet. The kubelet which is running in that node will run these health checks on that container, on that pod. So we can perform these ways. Liveness probe, we can execute a command and check. If this command returns a non-zero status code, basically, if the command, Linux command, if the command returns 0, what does it mean? If this command is successfully executed, basically what it returns, basically 0. If it is successfully executed, it will return 0. If it is returning 0, which means this is healthy. This is healthy. If it is not returning 0, if it is returning other than 0, in case of command, if it is returning other than 0, then does the kubelet will consider as a failure? If this command is going to be executed on this container, this command is going to be executed on this container, and if this command returns other than 0, then it will consider as a failure. If the liveness is failed, then will it restart the container? If the liveness probe is failed, will it restart the container? Yes. So we can execute a command and perform the health check. What is this period seconds, initial delay seconds? What is the meaning of this period seconds? Period seconds, how frequently that has to perform, the health check has to be performed. How frequently? So if I defined period seconds as 5, every 5 seconds, is it going to perform this health check? If I defined here as a 5, does every 5 seconds, is it going to perform the health check? Yes. So every 5 seconds. Initial delay seconds, this is most important. What is initial delay seconds? Initial delay seconds. Initial delay seconds will tell kubelet it should wait 5 seconds before performing the first probe. Before performing the first probe, initially wait for 5 seconds, don't start immediately. This is most important because does your container, does your process will take some time to fully up and running? The moment pod is scheduled, if it is start performing the health check, does health check might become successful? For the first time, when it is performing health check, if it is starting immediately, it may not work because your container, your application may take some time to fully functioning. So initial delay seconds. If I say initial delay seconds as 30 here, when the pod is scheduled, is it going to immediately start the health check at 5th second? If I mention initial delay seconds as 30, period seconds as 5, the moment pod is scheduled on that node, is it going to start immediately? The kubelet will start immediately at 5th second, the health check. If I define initial delay seconds as 30, no. No. It is not like it will check 6 times serving. Initial delay, when it is performing for the first time, wait for first 30 seconds. Wait for first 30 seconds, then only you start do the health check every 5 minutes, 5 seconds. Because does the application will take some time to fully function when it is scheduled for the first time? When it is created for the first time, it is going to take some time. So initial delay, wait whatever seconds I have mentioned here, don't start the health check immediately for the first time. But after 30 seconds, is it going to start health check for every 5 seconds? 35th second, 40th second, 45th second, like that. So that is what initial delay seconds. I can execute a command and perform health check. Similarly, will I able to perform health check on HTTP request? Suppose I have some application hosted in that container, some API hosted. Can I perform HTTP health checks like HTTP calls like this? HTTP get on this path, on this port, right? I can perform health check. Something like this, guys. The way I am doing this one, can I define this one in a liveness probe HTTP get instead of this? Instead of this, I can say this path, I am checking whether this is responding or not. This path, am I getting the response or not? Path, that application path, on which port, your container port, how frequently you have to check. You can perform liveness probe, readiness probe on HTTP calls also. Other than this HTTP and commands, what is the other one? TCP socket. So TCP socket will just try to attempt, kubelet will try to open a socket on the container on a specified port. Whether it will I able to reach that port or not, it will just check whether will I able to open a connection with that container on that port, TCP socket. So based on the use case, you can define a liveness probe, readiness probe using this TCP socket type of health checks, or you can perform HTTP health checks, or you can execute a command and check whether it is returning success or failure based on the use case. Now, I have some application running in this pod. Can I use HTTP health checks as a liveness probe, readiness probe for this application? I can use HTTP health checks in this liveness probe and readiness probe. So I can define like this. So I can define like this. Let me take this, or you can edit here itself. So here, for this, within this container, my application is running here or anywhere. I can define liveness probe, something like this. Liveness probe, this one, for this container, this application. So here within this liveness probe, I can perform these things: TCP or command or HTTP based on your requirement. I can say HTTP get. What type of health check I want to perform? HTTP get. Within this HTTP get path, what is this path? Is it always something like this? They have just given example. Is it like this? Is it like this? No. That is based on your based on your API. What API or what context you want to check? What is my context in this case? In this case, this is my context. If I just something like this, as of now, what is running on this? Is my application is running on the root context, the root path? No. In this use case, it is not running on the root context, root path. Just Tomcat is running on the root context. So now, in this case, this is my path. The port, on which port you want to check. This port is nothing but your container port. On which port my container is running? 8080. Then we have, if you want to pass some headers, if you want to pass some headers, you can pass based on your requirement, otherwise you can leave it. Now, initial delay seconds. Initial delay seconds. Suppose your application is taking, let's say 30 seconds or 60 seconds to perform the health, for the first time. I can say initial delay seconds as 30, then period seconds. Period seconds. So period seconds, like how frequently? Let's say application headers. What headers in the sense? If your application is expecting some headers to be passed for that request, for this request, if it is expecting you to pass some HTTP headers, then you can pass those headers. Otherwise, you can leave that. Now, if I say every, let's say, just to give an example, I'm giving period as 30, which means every 30 seconds it is going to perform. If I say initial delay seconds as 60, which means is it going to perform after 30 seconds or it is going to start after 60 seconds for the first time? For the first time, it will wait 60 minutes, then it will start performing 60 seconds. Similarly, there is a one more option called a timeout period. Timeout period seconds. The way you have initial delay seconds, right? You have a timeout period seconds. This one, timeout seconds in liveness proof. So what is the timeout seconds? What is the timeout seconds? Basically, this timeout seconds, if application is taking more time, even though application is working, if it is not responding, let's say if I say timeout seconds as 5, even though application is healthy, if it is not responding within 5 seconds, in that case we can still consider it as a failure. I'm expecting that response to be come back within 5 seconds. What is the default value of this one, guys? What is the default value of this one if I don't mention 1 second? Which means when kubelet is performing this health check, within how many seconds it is expecting the response back? By default 1. If it is not responding within 1 seconds, it will considered as a failure. It will be considered as a failure. But if your application is taking some time based on your requirement, if your application is taking some time, can I say I am okay even though if it is responding within 5 seconds, I'm still fine? In that case, can I say timeout seconds as 5? If your application is taking some time to respond and your SLA is also fine, that application SLA also says that even though it is going to take 5 seconds, I am okay. If the application is responding within 5 seconds also, I'm still okay. Based on the SLA, you can define that here. Timeout seconds. This is liveness probe. Similarly, can I define a readiness probe for this? Similarly, can I define a readiness probe like this? The readiness probe. Something like this. Readiness probe. Exactly same like this. How frequently you want to perform readiness probe? Let's say you want to perform for every 5 seconds, let's say. Something like this. If the readiness probe is performing every 5 seconds, if it is not healthy, then does this readiness probe will inform service to don't send the traffic to this spot wherever this readiness probe is failed? Yes. So let me show that. Now I have a liveness probe, readiness probe. defined. Now I have a liveness probe, readiness probes defined. We are slowly adding lot of things, right, in our container pod spec. This already you know. What is this, guys? Whatever I have highlighted, what is this? The resource request and limits. And what is these two? This liveness probe and readiness probe. Can I consider these as a health checks for my application? Can I consider these are health checks for my application which is running inside that? And what is this? What is this volume mounts? Volume mounts basically volumes. You are attaching some volumes for your pods. That can be a normal volume, that can be a config map as a volume. If required, can I pass environment variables also? If this container is expecting some environment variables to be passed, can I pass using that env? Yes. So I can add based on the requirement. Don't by heart anything. Don't by heart anything. Understand the concept. What is, why we are using this? Why we are using this? Tomorrow it might be a different application. Tomorrow it might be a different application, different use case. If you know the use case and if you know the solution, will you be able to write 100 lines of manifest files also if you required? 100 lines of manifest files also you can write if you know the concept, the use case. If you by heart something, it is not going to work. Now I have defined a liveness probe, readiness probe. Now let me deploy this application. With this, now if you see in this namespace, why it is showing 0 by 1 even though status is showing as running, even though status is showing as running, why it is showing 0 by 1? And if I see why I don't have endpoints for this service still, even though it is showing as running, why I don't have endpoints for this one? Why I don't have any endpoints so far? What is happening? Why, even though it is running, why it is showing not ready? Because when it will be shown as ready, when it will be shown as ready, when it will be shown as ready, and when it will be reflected in your service, it will be reflected in your service once the readiness probe is successful. Once the readiness probe is successful. What is the initial delay seconds I have given? Initial delay seconds I have given 60. So is it performing the health check till that initial delay seconds is finished? No. If you see, after initial delay seconds, it is showing ready, which means is readiness probe is successful on these spots, which means you can describe and also see, guys. You can describe your pod and you can see now. You can describe and you can see the probes, right? The probes, the liveness probe and readiness probe. If there is a really a problem here, here you could have seen that. Here you can see that the readiness probe is failed, or liveness probe is failed. The readiness probe is failed, or liveness probe is failed. Let me show that intentionally. Let me intentionally change something. Now I am giving a wrong path that is not at all there in my application in readiness probe. I am giving something like this, but I don't have this path. And let me apply that. Since I am using deployment, is it going to recreate pods with these changes? Whatever I am changing, since I am using a deployment, Does the parts will be recreated with these changes? Since I'm using deployment, yes, you are updating your part template. You are updating your part template. So you can see that is configured because you are using deployment and you are modifying your part template, pod information. Now, if you see initial delay seconds, after 60, it is going to perform a health check. But will health check will be successful this time? I'm intentionally make a mistake. Will the readiness probe will become successful after 60 seconds also? In that case, does these parts will reflect in the service? Does these parts will reflect in the service as endpoints after 60 seconds also? Now you see after some time. If you see, even after 70 seconds also, it is not showing ready. It is not showing ready, and it is not reflecting in your service endpoints. Why? What could be the reason? Liveness probe is successful. If the liveness probe is failed, here you could have seen the restart. If the liveness probe is failed, here you could have seen the restart as 1, 2, 3, something like that. How many times that container got restarted? Now liveness probe is successful, but readiness probe is failed. It is not showing as ready here, and service doesn't have any endpoint also. Service doesn't have any endpoint also. If I describe this one, what it is saying, guys? If you see what it is saying, HTTP readiness probe failed with status code 404. So if it is a HTTP health checks, what is the status code it will expect? What is the status code it will expect? It will expect status code. If it is a HTTP probes, it will expect any status code greater than to 200 and less than or equals to 400. It should be any code greater than 200 and less than 400. It can be 201, it can be 304, any status code. Within, it is less than 400, not equals to, it is less than 400 and greater than or equals to 200. So 404, what is the meaning of 404? 404, 500, 401, 403 HTTP codes. 404, page not found. I have intentionally done the mistake. Now, even though pods are running, the service will route the traffic to these pods. Even though pods are running, does the service will send the traffic to this one? No. We will not get any response. Now let me fix this issue. Why liveness probe got successful? Because I have given a correct path. I have updated the wrong path only for this one, for readiness probe. For the liveness probe, I have given the correct path. If I give a wrong path here, you can see that it is going to keep restarting. Okay. Now let me fix this issue. Something like this. Let me apply this. If you want to decrease that, initial delay seconds, you can change. Now after some time, right? After some time, after initial delay seconds, it will start performing the liveness probe, readiness probe. Then if the probes are successful, I can see that will be ready. and I can see that in the service endpoints also here. Let's see that. Let's see that. Let me watch this one. Let me watch this. Every 2 seconds, this will be executed. After some time, I can see the endpoints automatically here. If the endpoints is reflected here, which means the readiness probe is successful. Which means the readiness probe is successful. If I see the endpoints here, I'm executing watch. So it every 2 seconds. Now I can see here. Now is the readiness probe is successful on both the replicas, whatever we have for this service. Now will I able to access this one from outside? Yes. I will be able to access this one from outside or inside, whatever. Now let me intentionally simulate the same problem. Let me intentionally simulate the same problem. What I am going to do, intentionally I am deleting. But this time, is readiness probe is going to inform service, don't send the traffic to this one because the application is not responding. And also, does liveness probe restarts automatically? I intentionally removed this one. Now, if I watch after that sometime, I can see only one endpoint here. Only one endpoint here. Unless until the liveness probe restart. Right? So after some time, here I can see only one endpoint. If now do you see, is it automatically removed one endpoint from here? That is happened because of what? That is happened because of what? The readiness probe is failed. The readiness probe is failed. Now I have a liveness probe also. I think every 30 seconds I kept the liveness probe. If the liveness probe restart that pod, I mean to say restart that container, and again I can see here automatically. This way, will you able to perform the health checks on your containers, the applications which is running in your containers using this liveness probe, readiness probe? It's very, very important topic in the real time also. We are going to use these liveness probes, readiness probes. Is everyone clear, guys? What is liveness probe? What is readiness probe? What liveness probe does? What readiness probe does? And how many ways we can perform? TCP socket, we can execute a command and check, or we can perform a HTTP GET calls. Okay? That is how it works. Now I am not doing anything. If the liveness probe restarted that container after some time based on the time you have given, I can see that endpoint automatically will reflect here. Till then, the service will send the traffic to only this healthy pod. Is the request goes to unhealthy pod? Now, service has only one endpoint, that is healthy. The service will send the traffic to unhealthy pod where your application is not responding, not working. No. It will only send the traffic to the healthy pod. Okay. Let's see after some time. Now can I see the number of restarts as one? Who restarted this one? Who restarted this one? Liveness probe. Still it is not ready. Still it is not ready. Once the liveness probe, readiness probe confirms that this is ready, now it is ready. Now, will that reflect in your service endpoint? Can I see again both? So this is how we can use liveness probes and readiness probes, guys. In the CKA exam or CKAD exams also, they are going to give one use case like this. Create a pod with the liveness probe and readiness probe. They will give one use case, one requirement. Create a pod or deployment which has a liveness probe and readiness probe on these parameters. So first of all, you should know what is liveness probe, what is readiness probe, so that you can easily refer and create. In the interview also, they will ask, how do you perform the health check on your application in Kubernetes? Or they may give a scenario. My application is stop working, but my pod is continuously running. There is no issue with my pod process, container process, but my application is not responding. How can I make sure the Kubernetes service should not send the traffic to that pod? They will not ask direct questions sometimes. They will ask a scenario. They will ask a scenario. Okay. So you should be able to explain the concept for this one. Now notifications, right? Wilson is asking, sir, how do we notify if there is any issue in your pods, containers or nodes? That is using monitoring softwares. You can monitor your servers. You can monitor your Kubernetes cluster also using monitoring services like Prometheus, right? You can set up a Prometheus which can monitor your Kubernetes cluster also. If any pods are in pending state, if any pods are in crash loop backup, right? In that case, we will get the notifications. Using monitoring softwares, you need to create alerts. That is monitoring, telemetry. Now, let's try to understand the next topic called stateful set. What is stateful set? Guys, this is very important. Is everyone clear? What is liveness probe? Even though it's very simple topic, I explained in the live like how it is going to work. It's very simple topic, but very important topic at the same time. So now we'll try to go to the next topic, stateful set. What is stateful set in Kubernetes? In Kubernetes, if I want to schedule, if I want to deploy some workloads, I mean to say some application I want to deploy, I want to schedule. What are the things we have if I want to deploy some application? We have a pod directly, or we have a RC, we have a RS, we have a DS, we have a deployment. So far, we deployed applications using pod directly. But as we already know, is it recommended to create a pods directly? No. So we can go for these things, RC, RS, DS deployment. So what is DS? The daemonset we already discussed. If you want some application, some pods to be scheduled in each and every node in your cluster, each and every node in your cluster, you can go and create a daemonset. And we have a RC and RS, replication set, replication controller. We can scale up, scale down RC, RS, right? We can scale up, scale down RC, RS, right? Replicas. Instead of going for RC and RS, what is the recommended way to deploy applications? Our own applications? Deployments. Because of the whatever features we discussed. Because of the whatever features we discussed. Deployment is the recommended way to deploy what type of applications? Deployment is the recommended way to deploy what type of applications? Stateless applications. Stateless applications. But if I have some stateful applications, I can make deployments also stateful by using values. Deployments are usually used for stateless applications, but however, can I save the state of the deployment, basically that application, by attaching a persistent value? Can I make deployments also stateful by using a values if required? By using values, can I make the deployment also as a stateful by attaching the values, which we have already done? Database. I was using RS or I was using deployment to run the database also. By using values, we can make stateful. But but there will be a slight difference when I go for a stateful set with values. When I go for a deployment with values, there will be a slight difference. Suppose when I am using values with deployment, when I am going to use values with deployment, all of the pods of the deployment will be sharing the same value. All of the deployment, all of the parts of the deployment will be sharing the same value, which means if I create a deployment with 3 replicas, if I create a deployment with 3 replicas, suppose I created a deployment with 3 replica, let's say, let's take Mongo. If I create a deployment with 3 replicas, we are going to use value. But does each and every replica will get its own value, its own storage? If I create a deployment or RC or RS with multiple replicas, does the value will be shared for all the deployments? I mean to say all the replicas of the deployment. So the same storage for all the pods of that deployment or replica set. Same value for all the replicas of same value for all the replicas of the deployment or replica set. But if you want to run a stateful applications as a clusters, like a database cluster in Kubernetes, does each and every replica and does each and every member of that cluster, does it require its own storage? Database cluster, high availability in the database also, like storage also should be highly available. Now each and every pod should have its own storage. If I go for a deployment, is it possible? Does each and every replica will get its own storage, its own value? If I go for a deployment, will it be like this? It is not going to like this. You don't have an option at all. You don't have an option at all. Even though you want like this, you cannot achieve this one using, you cannot achieve this one using replica set, replication controller, or daemonset. You cannot achieve this one using replication set, replication controller, or deployment. This is not possible. This is not possible. So if I go for a deployment, all the parts of the deployment will be sharing same value. So this is your manifest, right? So here, if I am mounting like this some value, if I say 3 replicas, 2 replicas, is it going to use same value for all those replicas? If I am using deployment or replica set replication controller, yes. You will not get this kind of a storage. You will not get this kind of a storage. This part should have its own storage, this part should have its own storage, and this part should have its own storage. So you cannot achieve this one using deployment replica set. replication controller. I want to have a database cluster, database also as a cluster. I want to run some stateful application like a database clusters, Redis clusters, Kafka clusters within Kubernetes. So each and every member in the cluster should have its unique storage, because let's say if something goes wrong with the storage, or something goes wrong with this replica, that member, do I still have other members where I have my data? If I go with this scenario, even though something goes wrong with the storage or something goes wrong with this pod, that member, do I still have other members where they are having their own data maintained? High availability in the data also, multiple replicas of your data. So if you want to run those kind of workloads in Kubernetes, each replica should have its own storage, and each replica should have some unique network identifier. In that case, will I able to achieve that one using deployment, pods, replica sets, replication controllers? No. That is where stateful set comes into picture. So stateful set is a Kubernetes resource used to manage what type of applications? Stateful set is a Kubernetes resource used to manage stateful applications. Stateful applications like databases, Redis applications, all those stuff. Any application which is stateful, it manages the deployment and scaling of those applications, those pods. We can deploy those kind of pods, and also we can scale those pods also. Arvind is asking what is stateful, what is stateless. I explained in the Docker when I was before starting Docker volumes. Have explained what is stateful, what is stateless. I hope I have explained, guys. I'm not sure. I think I have explained, if I recollect. Did I explain what is stateful, what is stateless before I start Docker volumes itself? In the Docker itself, I have explained. Very simple, very simple. Stateless application is you are least bothered about the data. Even though that application, that part goes down and recreated, you are not worried about the data loss, because you are not maintaining any data in that application. You are not directly maintaining any data in that application, called as stateless. Suppose if you are maintaining some data in that application, right, in that software, using that software like databases, Jenkins, if you lose the data, that is not expected, right? So that is already explained, guys. Go through that recordings if you want in detail. Okay. Now, stateful set is resources used to manage stateless applications. It manages the deployment and scaling of those kind of applications, and also it is going to guarantee the order and unique network identifier and unique storage for each pod. Let's say if I'm creating a deployment with 3 replicas, when I'm creating a deployment with 3 replicas, when I'm creating for the first time, is those pods will be created one after the other, or all the replicas will be created at the same time? When I'm creating a deployment, if you observe, anytime, did you guys observe when I'm creating a deployment, all the replicas will be created at the same time? And also if I am using volumes, does all the pods will be having same value? Single value. The volume is also same for all the pods, and it doesn't have any network identifier, unique host names. You are not going to get a unique host names for a stateful, I mean to say, this deployment, right? If you see I have a deployment. The deployment has managing these pods. Let me go inside this, or you can execute from outside also. So are you going to get any standard unique host name, network identifier? If you see the host name, are you going to get unique standard host name for a deployments if you are creating a pods using deployment replica sets? Some random host names, right? You are not going to get a standard network identifiers and not going to get a standard values if you are going for a deployments and other stuff. But when I go for a stateful set, it doesn't create a replica set, rather it will create a pod with unique naming convention, something like this. If I am creating a stateful set with name Mongo, if I am creating a stateful set with name Mongo with the 3 replicas, if I create a stateful set with name Mongo and I'm creating 3 replicas, the naming conventions will be something like this. Mongo-0, Mongo-1, Mongo-2. So when I create a stateful set with name Mongo, just to give an example, it will create a pod with name Mongo-0 and then Mongo-1, Mongo-2 with unique network. Even though this pod, this replica is deleted, if it is recreated, is it going to have a same network identifier as a host name? Even though this pod is deleted, and if it is recreated, is it going to get a same network ID, network identifier, host name? Yes. So every replica of a stateful set will have its own state, which means if I create a stateful set with 3 replicas, is it going to have 3 values? I mean to say, if I'm creating a replica stateful set with the 2 replicas, let's say, this pod will have its own PVC and PV. This pod will have its own PVC and PV. So each replica of a stateful set will have its own storage. So if I create a 3 replicas, each will have its own value. So if I create a stateful set with the 3 replicas, how many values will be there for that stateful set? If I create a stateful set with 3 replicas, how many values will be there? 3. It will have 3 PVCs and 3 PV. So as I already told, the most common way to run databases, if you want to run databases also in your Kubernetes cluster, you don't want to go for an RDS, or you don't want to run your databases directly on the virtual machines. You want to run your databases also as a Kubernetes workloads. In that case, what is the recommended object in Kubernetes to run stateful, I mean to say database kind of an applications? Stateful set. So each of your pod is going to get a same network identity and same disk, which means same value across restarts. Even though the pod is rescheduled to a different node, right? It is going to get a same disk, same value, and same network host name. So that is feature supported by stateful set. Stateful set supports stable, unique network identifiers, which means each pod in a stateful set is given a host name. Each pod in a stateful set given a host name that is based on the application name and increment. So if I create a stateful set with name Mongo, the first replica will be given this name, and this is the host name of that pod, host name of that replica. As I already told, it is going to get a stable, persistent storage, which means each and every pod will have its own value, its own storage. It is just going to create that way. Now, how the sync will happen, how the data sync will happen between those three different storages? If I just created a stateful set with Mongo as 3 replicas, does it mean Mongo cluster will be up and running in Kubernetes? Just create a stateful set with 3 pods of Mongo database. Does it mean Mongo database cluster will be up and running? No. You need to set up the cluster. Database also have a cluster concept, guys. Anyone from database background here? Anyone from database background? As I already told, in database also we have a clustering concept, database clusters. The database clusters you can set up in virtual machines, or if you want to go for RDS, you can go for RDS. In Kubernetes also, I can run database clusters using stateful set. So the data sync will not happen automatically. You need to set up the cluster. Database clusters, right? You will have a primary database and you will have a secondary database. So as I already told, if I just create 3 virtual machines, forget about the stateful set for some time. If I just create a 3 virtual machines and if I install database software, can I call that as a cluster? If I create 3 machines, 3 virtual machines, in which if I install database, I have installed Mongo here or MySQL here, whatever it is. If I install Mongo in this machine also, if I install Mongo in this machine also, so each and every server will have its own storage. Each and every server will have its own storage. Does it mean your database cluster is initialized like this? If you just install in 3 servers, if you just install Mongo database like this, does it mean your cluster is up and running? No. There is a primary secondary database concept here. Now let's say your application, your database, right? Your application or database client, we call it. So if I just create 3 database servers or whatever it is, if your application connected to this server for one operation, it has connected to this server and it has inserted the data. So again, other application, if it is connecting to another server to get the data, whatever data is persisted by connecting to this server, will it reflecting in this server in this storage automatically if you just install 3 servers? No, right? So there is a clustering concept here, guys. So we have a primary database, we have a secondary databases. Primary, all the write operations will be carried via primary, all the read operations will carry via secondary. In that case, does your primary database should know where is your secondary database is running to flush the data, to sync the data? Suppose this is my primary DB. So all the write operations is carried via this primary and all the read operations will carried via secondary for high availability, to reduce, to improve the performance. You will take all these things. All the read operations will happen via secondary. Now Does this primary database should know where is your secondary databases are running to flush the data, whatever data is writing in this primary DB, does it need to flush or sync the data to the secondary DB instances? Yes, right? So in the database, we have to set up that cluster concept here. In one of the database replica, you need to initiate the DB cluster. In one of the database, whether that is a server, that is a pod, doesn't matter. You need to go and initiate DB cluster. Then you need to join, or you need to provide these two server details to this primary. So if this primary has these secondary server details, does primary will flush the data or sync the data to these servers, these secondary database replicas? Yes, right? For some reason, if this primary database has a issue, for some reason this primary database is down, does this, out of these two secondary databases, does one server will become a primary database if there is a issue with this primary? Out of these two, one guy will become a primary again. But all the databases are in sync because primary knows where secondary is running, secondary knows where primary is running, all those details. So this is what database cluster setup. Now same setup, if I go for an RDS, do I need to do all these things? Do I need to create a virtual machines? Do I need to initialize the primary, secondary if I go for RDS? No. Who will take care of that one, guys? Who will take care of that one? That will be taken care by completely AWS. Now if required, can I set up these kind of a environment in virtual machines EC2 on my own? I can create 3 servers. I can install Mongo database in all the servers, and each server will have its own EBS volumes, EBS storage or whatever storage. One of the database I can initiate primary. I can add these 2 machines as secondary here. In that case, who is responsible for setting up the cluster and taking the backups of your storage, your database? If I directly go and do in EC2, we are responsible. Same setup if required, will I able to do in Kubernetes using pod? Same setup, can I run my Mongo database in Kubernetes as a pod? But if I go for a deployment, am I going to get like this 3 each pod? Is it going to get its own value? If I go for a deployment, am I going to get this way? So all the pods, all the replicas of your deployment will get the same value. But if I want to set up these kind of a cluster, does deployment will suffice my requirement? Does deployment will support my use case, this use case? No. In that case, can I go for a stateful set? So that each pod, each replica of your stateful set is going to get its own storage? And also, am I going to get a stable names, host names, Mongo 0, Mongo 1, Mongo 2? So even though this is recreated, does the host name will be changed? Suppose I am going to use this one to set up that database cluster. Here I will add, these are my secondary replicas host names. I am saying this is one secondary host, this is one secondary host. Even though this is deleted, if I recreated, if stateful set is recreating, is the host name, is the network identifier will be different? Is this network identifier will be changed? No. And even though this is deleted, when it is coming back, it is going to use same storage, whatever it was using earlier. Which means, am I going to get a stable volume I mean to say stable storage and stable network identifier, that host names. Yes, right. Now, when we are using stateful sets, there is a one more concept called headless service. There is one more concept called headless service. Sometimes in the interview also they are going to ask, what is headless service? Headless service. Chandan is asking which one is preferred, RDS or stateful set. If I am, if you ask me, I will go for an RDS because I don't want to take a headache, or I don't want to take the headache, or I mean to say I am very lazy. I don't want to manage databases on my own using virtual machines or Kubernetes cluster. I don't want to set up. I can just go for an RDS. But if your client is saying, I don't want to go for RDS because of the charges, the AWS is going to charge huge money when I go for an RDS. I already have a Kubernetes cluster. I already have my applications running in a Kubernetes cluster. Let's deploy database also within a Kubernetes cluster. I don't want lot of billing, lot of amount which I want to pay for RDS. Let's deploy in Kubernetes itself. In that case, you can go for a stateful set. But if you go for a stateful set, are you responsible for doing all this kind of a setup, creating a stateful set, initializing the clusters? I mean to say your database cluster, going inside this, you need to execute some commands and make this as a cluster. That is based on your use case, based on your requirement, based on your billing. Which one is completely depends on your requirement, your use case guys. If your client, I don't want to go for RDS because they are charging huge money. I don't want to pay that much money every bill, every month. You already have a machines you are using for Kubernetes. Within that Kubernetes cluster itself, you run the database also as a cluster. Then stateful set. If your client says, I don't want to run my database workloads in Kubernetes, I want to have only application workloads in Kubernetes, let's run database in a separate servers. Maybe you can go for an RDS, or you can create a servers in VPC and create the setup. That is completely based on the use case, guys. Okay. That's why I'm saying from day one, there is no real time. What do we do in real time? Nothing we do in real time. Whatever I am doing in the classes, same thing will be done in the real time also. As I already told, there will be a requirement, there will be a use case, there will be a use case, there will be a requirement. For that use case, I need a solution, and you have to follow the best practices at the same time, right? And if client is okay to have a database in RDS, I prefer RDS. If client is not okay to have a database in RDS, I will set up in the Kubernetes. But if I set up in a virtual machine, if something goes wrong with your Mongo process in that virtual machine, will it be automatically recovered, restarted? If I directly set up in a virtual machine, if there is issue with your virtual machine, the database process is not running, will it be restarted, recreated automatically? No. That is how it works. Now, there is a one more concept called headless service, guys. There is a one more concept called headless service. What is headless service in Kubernetes? So far, what type of services we discussed? We discussed cluster IP, we discussed node port. There is a one more service called load balancer, which we will discuss later. This is external load balancer. Now we have a one more type of service called headless. What is headless service? I need a service, I need a DNS, I need a DNS without load balancing. I need a DNS without load balancing, which means If I have a multiple replicas, I don't want load balance to happen between those replicas in Kubernetes. I don't want load balance to happen in Kubernetes. Then I can go for a headless service. Because if it is a database, does your application has to talk to all these replicas? Because it doesn't know which is primary, which is secondary, right? It should has to talk to these things directly. There should not be any load balancing. Your application or your database client has to talk to all these replicas. Now, if I create a service of normal cluster IP, if I create a normal service like a cluster IP, does this service does the load balancing between these replicas? If I create a service of type normal cluster IP or node port, does the load balancing between three replicas, these replicas? We already discussed. Within the Kubernetes, does this service will act as a load balancer, guys? Normal service like cluster IP service. If the service has three replicas, if I create a normal service like a cluster IP service, is the load balancing is not happening between three replicas or two replicas? This pod has a labels, something like this. Service has a selectors, it does the load balancing. But if I have these kind of a workloads within my Kubernetes, database clusters, Kafka clusters, or Redis clusters within Kubernetes, I don't want that clients, that applications to use a normal service. I don't want a load balancing between these replicas. It has to talk to all the replicas. In that case, we can create a one type of service called headless service. Sometimes in the interview also they will ask, what is headless service? If you see, sometimes you don't need a load balancing and you need a service. In this case, you can create a service of type headless service. Sometimes you don't need a load balancing and you need a service, DNS resolution. In this case, you can create a service of type headless. How can I create a service of type headless? By creating a service, in the service spec, I can say cluster IP as none. So in that case, you are not going to get a service IP. That cluster IP. It does not do the load balancing. For headless service, the cluster IP will not be allocated. Kubeproxy does not handle these services, and there is no load balancing for these services. So we can create a service of type headless for this kind of a requirement. Now, let me show you. I'm going to create a stateful set for a database now. I'm going to create a stateful set for databases now. Something like this. Stateful set. And also, I need a service of type headless because I don't want load balancing to happen. So I'm creating a stateful set like this. Stateful set. API version is this. What is the kind? What kind of object I'm creating now? For database, kind is stateful set. Here, we need to mention the service name while creating a stateful set itself. You need to give the service name. What is the service which you are trying to use for this stateful set? So I'm creating a service. If you see what this represents, cluster IP none, which means what type of service is this? If I say type as cluster IP, if I say type of cluster IP, then I will get a cluster IP service. It does the load balancing. I don't want the load balancing, so I am saying cluster IP none, which means this is what type of service? This is what type of service? Headless service without load balancing. So this service name I am mentioning here. This service name I am mentioning here in my stateful set spec. Now let's say I am saying three replicas. So how many pods will be created for this database? 3. So for cluster, it is not going to take this way, guys. It is not going to take this way. Your username and password cannot be set up this way. I'm removing those environment variables, right? Now, volume mounts. So 3 replicas. It is going to use 3 volumes. But here, in case of deployment normal pod, how I was defining volumes? How I was defining volumes? I was defining like this: volumes, normal volume or persistent volume. But in case of stateful set, we are going to define as a volume claim template. So because it is going to create number of PVCs based on these replicas. Now I have 3 replicas. It is going to create a 3 PVCs with this information, volume claim templates. In your stateful set itself, you are defining your claim template, PVC template, which means using this template, how many PVCs will be created? How many PVCs will be created with this spec? Here number of replicas has been given 3. If I given number of replicas as 4, with this PVC information, how many PVCs will be created? I no need to explicitly create a PVC. With this information, PVC will be created. If I say number of replicas as 4, how many PVCs will be created? 4. If I say number of replicas as 3, 3. But do I need to have 3 volumes available for these PVCs to be claimed? Do I need to have already volumes available for this? It is going to create a PVC. The volume should be available. At least if the volumes doesn't exist, if I have a storage class, if the volumes doesn't exist, if I have a storage class at least configured, does that storage class will provision the volumes for these claims? Yes. If I don't have a storage class, if I don't have a volume, then whatever claims is being created by the stateful set, will those claims will get the volumes? If the storage class is not there and if you don't have a PV also, then it is not going to work. But do I have a storage class, guys? Do I have a storage class already configured in my Kubernetes cluster? Yesterday we configured, I think day before yesterday. I have a storage class. Now, when I create a stateful set like this, it is going to create 3 PVCs and it is going to have a 3 volumes. Okay. Now, service. Now, my application. Suppose this is my application. Right? My database pod. My front-end application. So now, this is my front-end application where I am creating a deployment for my front-end application with 2 replicas. I am passing database username, password. The host name I am passing as this service name, headless service name. I am passing as that host name. Now with this manifest, Let me deploy application. But before that, let me delete, guys, whatever I have. Whatever other applications I have, let me delete that. So I'm creating a stateful set for my database with how many replicas? How many replicas? I'm creating 3 replicas. I'm creating a stateful set for database. Now, I'm just creating a stateful set with 3 replicas. If you see, these values are for different requirement it has been created, right? For previous things it has been created. Now, let me apply this. Now, if you see, is database pods are getting created at the same time. If you see, is it creating one after the other? If you see, the deployment pods created at the same time. But when it comes to stateful set, first it will create this replica. Once this is come to the running state, then it goes to this one. Once that is also done, it goes to the third one. But I have 3 database pods running, and each pod will have its own PV and PVC. Can I see now? This one, Mongo 0. This one, Mongo 1, Mongo 2. Like this, each has its own value, its own volume claim, its own volume, its own volume claim. Now, if I just create a 3 pods, does it mean the database cluster has been running upper successfully here, or I need to do some kind of a configuration within that to initialize the primary, initialize the secondary? Now it is like simple, 3 pods are running. It is just simply running 3 replicas like this. It is just running like this. There is no primary, there is no secondary. Now I can add one as a primary and I can configure. So that is database concept, guys. That is database concept. Now we have a database administrators also in the real time, but if you are already experienced resource, you are kind of a senior guy in IT, you might, like 10 to 15 years of IT experience you have, you worked in all the areas, right? You would have done that one also. Now I need to set up that kind of a primary secondary. Now database replica set, MongoDB, we call it as a repel set or replica set. MongoDB replica set is different, it is not Kubernetes replica set. So repel set in the Mongo database is a group of Mongo database process that contain same data set. We need to set up that one. If by going into one of the pod, you need to inform what is secondary, what is the secondary instances. You need to join those members. The way we have joined members to the Kubernetes cluster, right? Similarly, I need to have that kind of a setup. This is not the right file. One second, guys. This is not the right file. Let me take this. One second, I need to update this one. This is not the right file. line number 1 to 43. So same thing, but actually I'm passing some commands. If I want to set up Mongo database as a cluster, right? The Mongo process has to start with these arguments. Mongo process has to start with these arguments. So I am passing these arguments, command line arguments, which means these commands will be taken as an arguments and the Mongo process will be started. If I want to start Mongo database, if I want to set up the Mongo database in a REPL set, that cluster kind of a setup, I have to use this option. So I am using this option first. Let me apply this. Let me apply this. So there is a change. If you see, first this is created, then this will be removed, guys. The creation will be in an incremental order. The creation will be in an incremental order. The deletion will be in a this order. It will delete this one first, then this one first, this one last. That is how the stateful set works. Okay. So once this is ready, it is going to delete this in the reverse order. It is going to terminate in the reverse order. Why I am reapplying, because I missed to pass some arguments, these arguments. So I am passing that one now. I think my cluster is gone. My cluster is gone because too many pods now. Gone. If you see, already this node went not ready because lot of pods are getting created. It gone. Let's do one thing. I'm deleting all the things. I'm deleting everything, right? I'm deleting everything. I have only one option. I have to stop and restart. I have to stop and restart this one. That whatever node which is went not ready. I have deleted all these things, guys. All the applications, whatever has been deployed. I will stop and restart that server, this server, so that again it will become to ready state. Then I will continue tomorrow. Okay. I have not explained basically. I have just explained what is stateful set, but I have not yet deployed the Mongo database as a stateful set. I have not yet deployed. I'll continue tomorrow because anyhow it is going to take some time. If I have to stop that server and again start that server, it is going to take some time. I deleted all these things, whatever has been deployed by executing this command. Then I'm going to stop and start this server. We'll continue tomorrow. Tomorrow I'm going to deploy stateful set, Mongo database as a stateful set. And also I will initialize database, Mongo database as a cluster, primary database, secondary database. We'll continue tomorrow. Very, very important topics, all these things. Okay. Try to understand all these concepts. I'll continue tomorrow. We need to give a less load for our cluster tomorrow. Yes, definitely. Otherwise, I will change the instance type. I'll change the instance type. Maybe I'll go for t2.medium instead of t2.micro. I'll change the instance types and I'll start the servers so that I can deploy more applications. These kind of things also happening for a good reason, guys. If you understand, in real time also you are going to have these kind of issues. You should be able to understand why it is not ready, how to troubleshoot, what is happening, what is the problem, why parts are impending, why nodes are going down. These things happens in real time. That is why we are here. Why this is happening, how to make sure this should not happen. It's a better experience for you guys, the real-time experience in your words. Thank you guys. I'll continue tomorrow. It's already late. I'll apply a stateful set and I will demonstrate tomorrow the Mongo database stateful set. Thank you. We'll see you tomorrow. But try to practice liveness probe, readiness probe, whatever has been discussed today. I'll see you tomorrow. Thank you.